Very good morning to all. Myself Abid Mullah from JSPM Rajashri Shaw College of Engineering, Tataude, Pune. Today I am going to presenting my research paper named as Design and Simulation Modeling of Four-Wheeler Electric Vehicle in 8th I2CT 2023. So these are the content of my presentation: introduction, problem formulation, after that proposed work and methodology, after that software simulation, after simulation result, after that conclusion and future scope and references are there. So let us come to the first point, introduction. As we know that central government of India is going to providing the many initiatives and incentives for promoting the electrical vehicle in the market. For example, tax incentives for electric vehicle owner, public EV charging station, charging infrastructure development, and FAME, which is called as faster adoption and manufacturing of hybrid electric vehicle. This is India's flagship scheme which going to promote electrical mobility, having the budget of 10,000 crores approximately. So government of India is going to providing huge amount of money and providing many policies for users to promote the electrical vehicle in the market. Problem formulation. As we know that government of India is taking many initiatives and subsidies to promote electrical vehicle in the market, but still we observe that the use of electrical vehicle is not as per the expectations because of some reasons are there. First, less accuracy in design of vehicle dynamic parameters, motor parameter and the battery parameters are there. Second, charging infrastructure, less availability of the charging infrastructure in public and in private domain. Third, battery swapping. Fourth, safety precautions and less performance, and many more problems are there. So in this research article, we had a design the adaptive intelligent vehicle controller and design of vehicle parameters and other design values of vehicle. We had designed this all these intelligent vehicle controller, vehicle dynamic parameters and other vehicle values in a such a way that your vehicle performance will get improved and your vehicle should able to accurately track the reference speed with your actual speed of the motor to improve the accuracy and the performance of the electric vehicles are there. So the thing is that by accurately designing of the vehicle controller and the other design parameters, we are going to increasing the accuracy of the design and we are increasing the performance of the electrical vehicle is that. This is a proposed work and methodology is there. In that we can here we can able to see the motor and the vehicle dynamic parts are there. In that we had taken the permanent magnet DC motor. Vehicle dynamics means aerodynamic drag, rolling resistance, uphill and downhill resistance. This all comes under this motor and vehicle dynamic part. Battery, okay, we had taken the lithium ion batteries are there. After that, in order to measure the state of charge of the battery, we had taken here the state to measure the battery state of charge. Here you can able to see the longitudinal driver which can able to accelerate or de-accelerate or which can able to take the necessary action to increase or to decrease the speed of the vehicle. Here you can able to see the drive cycle source are there. We have the different types of the drive cycle source are there. So at every different drive cycle, if you observe previously, at every different drive cycle, your vehicle is not accurately tracking the reference speed. So that's why the accuracy and performance of vehicle is goes on reduces. But in this proposed work, we had designed our longitudinal inside the longitudinal driver. We have designed our adaptive intelligent vehicle controller in a such a way that at any different drive cycle, your actual speed and reference speed both are approximately same. So that because of actual and reference speed both are same, your vehicle is going to tracking, your vehicle performance and accuracy goes on increasing. Now this is the simulation diagram for our for my proposed work. In that you can able to see here the drive source systems are there. from here you can able to select the different drive cycles are there. Okay, FTP is there and ULTP is there. Okay, different types of the drive cycles are there. Okay, here we can able to select the different types of the drive cycle trains. Here you can able to see the vehicle driver. Inside that vehicle driver we had designed the vehicle controller. We had provided the values of that vehicle controller in a such a way that your motor, here you can able to see the motor should able to give the uh, motor should able to provide the speed which should be exactly same as the speed of your reference speed is that. Okay, so and here you can able to see H bridge and PWM generations are there in order to generate the PWM pulse to your motor is that. Here you can able to see the four-wheeler vehicle is that, in that the four wheels of the vehicle are there. Here you can able to see the vehicle dynamic parts. We had designed the different aerodynamic drag, rolling resistance, and all other dynamic parameters in this block. Okay, and we have designed the different values for the vehicle wheel of the four-wheeler electric vehicle. Here you can able to see the batteries are there, and from that battery, as the use of the battery is increases, utilization is increases, the state of charge of batteries goes on decreasing. That we had also calculated the state of the charge of the battery with respect to the load or with respect to utilization here. So this is a simulation diagram is that, in that we can able to select the different drive cycles. So your vehicle should able to track that reference speed. Okay, so after successfully running this software simulation, we can able to observe the results are over here. So here you can able to see the figure number 1, the reference speed and actual speed waveform for US Environmental Federation Test Procedure FTP 75 drive cycle train. Here we had selected the FTP 75 drive cycle train, which is having some kind of the uh, uncertain waveform, uncertain vehicle drive cycle is that. So your motor should able to actually track that unequal drivetrain cycle, unequal drive cycle source is that. So here you can able to see the reference speed and actual speed both are matching, both are overlapping with each other. It means that whatever we are expecting from the drive cycle reference speed, that same speed is going to get tracked by the our vehicle controller is that. So there is no difference between actual and reference speed is that. Here also you can able to see for the second different cycle, that is a WLTP cycle, Worldwide Harmonized Light Vehicle Test Procedure. So from here, drive cycle, we had selected the WLTP, which is having the nature in this way. Okay, this is the nature of the reference speed, and your actual vehicle is going to tracking, actual speed of the motor is going to tracking the reference speed, and there is no difference between the actual and reference speed is that. So because of the, and both are overlapping, because of that accurately tracking of the reference and actual speed, the vehicle performance is goes on increasing. Okay, and after that also we had considered the another cycle, that is a New York bus cycle. Okay, we had selected another different New York bus cycle, and this is the nature for that New York bus cycle, and our designed controller is accurately is going to tracking that uncertain and non-linear route of the speed. Okay, and there is no difference between actual and reference speed, and because of that both the reference and actual speed are overlapping with each other. So from these results we can say that our designed parameters of vehicle dynamics, motor and the battery, and motor and battery, and also our designed adaptive intelligent vehicle controller will accurately track the reference speed, whatever the needed from the source. So because of this accurately tracking, your vehicle performance and vehicle performance and accuracy of the vehicle is get increased. Also here you can able to see I had shown the state of charge of the battery. Initially the state of charge of the battery is 1, means which is 100% because it is not utilized. But after once the utilization is going on, As the utilization is increasing, the state of charge of the batteries goes on decreases, and after here you can able to see the state of charge of the battery is 89%, approximately 89% is that. So from that we can able to say, as the state of as the utilization of the battery is increasing, the consumption is increasing, the battery state of charges goes on decreasing is that. Okay, so here is the conclusion and the future scope. So from above research article, we can conclude that we had designed the adaptive vehicle controller and vehicle dynamic parameters, and we had designed the PWM, we had designed the motor parameter and battery parameter, which are accurately going to tracking the actual and reference speed, so that the vehicle performance is goes on increasing. Otherwise, in day-to-day life, there is a difference or the mismatch between the reference speed and the actual speed. Is that this problem is get overcome in this research work by adaptive design of the vehicle controller, and all other parameters are there. So from this we can conclude that research article, we can conclude that uh, mm, our design vehicle controller and other parameters are used zero error between, or the less error between actual reference speed and the actual speed, which will going to improve the vehicle performance and the performance of the vehicle, so that in future definitely the more customer will going to use the electrical vehicle in the market. Regarding the future scope, the hardware in the loop testing of the proposed four-wheeler electric vehicle will be the future scope of this simulation work. Now, these are the some references I had referred to do my research work. Okay, so these are the some 5 references I had referred to do my research work. And so with this, I will conclude over here. Thank you very much.